Hey everybody. Today we're getting started with scatterplots. We're in a situation where we have paired data. That is, we have a bunch of observations of two variables where observations of the first one match up exactly with observations of the second one. For instance, we might have math and verbal SAT scores for a bunch of students. So each observation includes a student's math and verbal score. Heights and weights of individuals in a medical study, dollars spent on advertising, and numbers of sales per month for various candy bars. Again, in each case, values between the two variables match up with one another exactly. The most common and important way of visualizing paired data is the scatter plot. And we take those two variables, and we take the observations, and for each one we make an ordered pair, x, y, and then we plot those on a standard Cartesian coordinate plane. Here's an example. The table that I'm showing you is showing the number of doctorates that were awarded in the United States in various science and engineering fields in 2005 to men and women respectively. So for instance, the first column, 224 and 333, represents the number of doctorates that were awarded in one particular field in that year to women and men respectively. So I'm going to put women on the x-axis and men on the y-axis for no particular reason to get a scatter plot. Here it is. Each observation has 1 point, so if you count up the number of points in this plot, you'll get exactly the same as if you count up the number of columns that have numbers in it in this table. And I've labeled a few of the points for clarity. For instance, that observation 224, 333 in the lower left of the plot matches up exactly with the first numerical column in this table. As with single variable plots like histograms, we can talk about scatter plots qualitatively and develop vocabulary for those descriptions. We can talk about shape, center, and spread, just like with histograms or frequency polygons or whatever. Center and spread get us into regression and correlation, so right now we're just going to talk a little bit about shape. Here's an example of a scatter plot with an upward trend, in the sense that as x gets bigger, y usually gets bigger as well. Now, of course, that's just a general trend. It's not a rule. Sometimes if you compare 2 points, one will have a bigger x value but a smaller y value. In a plot like this, we say that the two variables have a positive association, or that they're positively associated. It's not quite correct to say that it's a positive correlation, because the word correlation is reserved to talk about linear trends in scatter plots. Also notice that in this plot we have an outlier. It's unusual in the sense that it lies outside the overall trend of the data. And an outlier can be a mistake, just like a data entry error. It could be a bizarre case that should be ignored or treated separately. Or it could be a very interesting phenomenon in its own right. And the example I usually give there is if you're considering disease resistance and you have one patient that just seems to not be susceptible to the disease you're looking at. That's the patient you probably want to focus on the most to try and figure out what's interesting about their physiology. Sometimes in a scatter plot, one of the two variables can be viewed as explaining the other one. And we always put that variable on the x-axis, on the horizontal axis. In situations like that, we call the variable on the x-axis the explanatory variable, because it does the explaining. We call the variable on the y-axis the response variable, because our perception is that it is responding to the values that the x variable takes. If we were in a more algebraic scenario, we would call x and y the independent and dependent variables respectively. When we're in statistics, we generally use these terms instead, explanatory and response. For instance, if we're talking about weight of cars and gas mileage of those cars, there's kind of an obvious choice for which one you consider to be the explanatory variable. It seems like it makes more sense to explain MPG with weight than the other way around. So in this case, we're putting weight on the x-axis of our scatter plot.